Alright, so I'm having way too much fun with this screencasting. So I thought I'd talk a little bit about the Gini coefficient. So I want to start by drawing a line here. And this is going to be the line of everyone in society. We're going to start with the poor people, the poorest people, down here. Okay, put this person at 0. And this person looks like this. He's sad. And the reason why is because he doesn't have any money. No DKK. Over here, it's going to be 1. This is going to be where the rich people live. So this is going to be a nice rich person in a top hat. Kind of fat with a monocle. Oh, I do say so, sir. Okay. So there's our rich person. So we lined everybody up in society, and we put them on the line from 0 to 1 in order of their income. All right? And then over here, we're going to have another axis. All right, and again, we're going to label this axis from 0 to 1. So up here is going to be 1. And this is going to be what fraction of total income do people have? Okay, so I should be a little careful here. So suppose we look here at 50%. So this is right in between 0 and 1. We've lined all the people up. So right here at 50%, we want to ask, what fraction of total earned income do people have if they're on this part of the line, under 50%? So the cumulative share of population, up to 50%, what's their cumulative share of income? Let's suppose that it's, say, down here, maybe 30%. That's about 30%. So we'll put a little dot here. Okay. So the bottom 50% of people, they earn 50% of all of the income earned, or 30% of all of the income earned in the country. You know, we might say 25%. So maybe the bottom 25% of people, maybe they earn 10% of all of the income earned in the country. All right, and up here, 75%, maybe 75th percentile earns, let's say, 50% of all of the income earned in the country. And then let's connect those dots. Not so easy to do it in a smooth way. It's supposed to be nice and smooth. And this thing here, this curve, is what's called the Lorenz curve. Okay? And the reason why we care about it is because it's used to calculate the Gini coefficient. So what is the Gini coefficient? I'm going to switch colors here to make things more clear. So if we were to draw a straight line between 0 and 1, this is the line that represents equal income. So it says the bottom 50% of people in society, they have 50% of the total wealth, total income. Bottom 25% of people in society, in terms of income, they have 25% of the total income. So in other words, everybody has exactly the same income along this red line. So that's total equality. Right? So what is the Gini coefficient? The Gini coefficient is actually just the middle here. It's just this area here between these two lines. Right? So it's just the area of the space in between these two lines. So again, this red line represents perfect equality. So the blue line, the farther it is away from the red line, it turns out that means that there's more inequality. And in particular, you can imagine a society where everybody has 0 except for the person at the top, the person with all the income. That would just look like this. I'm going to draw it now with yellow. That would just be, the Lorenz curve would be like this, because everybody has nothing until we get to the very richest person, and then that person has everything. So that would be like the maximum Gini. The area between the red curve and the yellow curve actually would be 1. And now that I've said that, I realized I'm defining the Gini slightly incorrect, because actually this area between these two curves, you can see it's a triangle, and we know it here it's 1, there it's 1. This is actually 0.5. So the Gini coefficient, I should be careful. This green area here, let's look at this one. Let's call this green area right here. Let's call that B. Get rid of that thing. let's call this area B. And then let's call the blue area, so this area down here, let's call that A. Then the Gini coefficient is actually equal to it's B divided by A plus B. Okay, so then in this case you can see, so in other words the fraction that the green area is of the area in this triangle. All right, so in this case, this yellow line that represents perfect inequality where one person has all the income, well then you can see that the green area, if we were to draw it, would be the entire triangle. So then the fraction of B, or the Gini coefficient, would be equal to 1. Here, the green area, the way we've drawn it here with the blue Lorenz curve, this, the green area is, say, a little bit less than half the area of the triangle. So then this would be like 0.4 or something for the Gini coefficient. Okay, so I've got one more thing I want to talk about. So we can also, we can also write down the mathematical expression for the Lorenz curve. And the reason why I think it's useful to do that is to think a little bit about what the Lorenz curve really means. So let's just draw one more, just to have something up here to look at. So let's just draw a Lorenz curve, like that, and then that looks something like this. Okay, well we can certainly see a couple of things about this curve already, right? We can see that the slope is increasing always, and we can see that it's convex. So, there's a question, would this be convex for any income distribution? Or is it just income distributions that we're used to seeing that the curve is convex? And, what does it mean? What does the slope of this curve really mean? Like, suppose that the Gini curve, the Lorenz curve is very flat for a while and then it gets steep at the end. What is the slope? What does that really mean? Okay, so if we actually write out the expression for the Lorenz curve, well, we can see that it's a function of the percentile, the income percentile of the population. So I'm going to write L of F of M, and M is income. Okay, so the way this works is F of M is like the fraction of the population that has less than M for its income, and then the Lorenz curve is a function of that fraction. All right? So that is equal to going to be the minimum income, so I'm going to say the minimum income is 0. This could actually be negative infinity. You could have people with negative income if you like, but just for the sake of keeping things clear, let's suppose that the least income you can possibly have is 0, and let's say we're going to go here up to M, okay, and then this will be T F of M, screwed up, TF of T, dt. So what this is this is the average income among everyone who earns an income somewhere from 0 to M. Okay? And then F here is the distribution of income in the population. This F here, if you know distributions, this is the PDF, the probability distribution function, right? And we're going to divide that by mu, where mu here is the mean income, mu for mean because mu is the Greek letter for M. This is the mean income over the whole population, all right? So let's think here about what is the slope of this Lorenz curve. How can we interpret the slope? Well, it's going to be dl df, right? Because down here on the bottom we have f, we don't have m. This f goes from the cumulative distribution function goes from 0 to 1. So that's not exactly what we want, because we want to have something that has an m in it over here. So let's do a little bit of Leibniz notation fun and do dl dm dm df. Right? Well, dl the MDF is easy because the probability density function is just defined as the derivative of the distribution function with respect to m. So this is actually just 1 over the probability density function. Okay, so we've got that one already done. Now how about this guy? What is that? Well, we have to take the derivative of this expression on the right here with respect to m. Well, you can see that m only appears up here in the limit of the integral. So if you know your rules of integration, we just have to plug this m into the integrand. So then we'll get m times f of m divided by mu. That thing sticks around. And then look at that, we've got 2 f of m's here, we can cancel them. These are always greater than 0, of course. And we end up with m divided by mu. So what is the slope of the Lorenz curve at any point? It's just the income that's associated with that percentile. So, so say we're looking at the slope at 0.5, so the median person. What's the slope at the median person? Well, it just happens to be the income of the median person. That's the slope. So, so when we look up here, the slope here is going to be very steep because that's the income of the richest people potentially could be very steep. Down here, the income of the poorest people, that's going to mean that there's a very flat curve, that the slope is very low. And moreover, you can see that this curve is always going to be convex because the slope is the income of the person associated with the percentile, and the percentile is just defined in terms of income. So the slope is always increasing as we move to the right on this line. And of course, if the slope is increasing, that's the definition of convexity. So that's all I have to say about the Lorenz curve and the Gini coefficient. I'll just leave it there.